Welcome to SpaceTime with Stuart Gary.
A new study has concluded there are at least 2 trillion galaxies, some 20 times more than previously thought, in the observable universe. The findings, reported in the Astrophysical Journal, are based on a new study of data from the Earth-orbiting Hubble Space telescope as well as other ground and space-based observatories. The data from the Great Observatories Origins Deep Survey, or GOODS, is the most accurate census of the number of galaxies across the cosmos ever undertaken. As well as having implications for science's understanding of galaxy formation, the results also help to solve an ancient astronomical paradox. Namely, with all the stars around, why is the sky dark at night? One of the most fundamental questions in astronomy is just how many galaxies does the universe contain? Images, including the Hubble Deep Field, the Hubble Ultra Deep Field and the Hubble Deep Field South, have provided astronomers with their first real insights into this question by showing them a glimpse of the myriad of faint galaxies revealed in just one tiny section of the sky. It allowed scientists to estimate that the observable universe contains something like 100 billion galaxies. But there's a problem. You see, the limited speed of light, namely 300,000 kilometres per second in a vacuum, combined with the age of the universe, just 13.8 billion years, means that based on the universe's expansion out from the Big Bang, limited by gravity, and multiplied by the estimated accelerated expansion dark energy has had on space-time, means that only a tiny fraction of the estimated 93 billion light-year-wide size of the universe can ever be seen from Earth. This small window is known as the cosmological horizon. Now, a study led by Christopher Kinsellas from the University of Nottingham has shown that this 100 billion galaxy estimate is at least 10 times and more likely 20 times too low, meaning that the cosmos contains at least 2 trillion galaxies. Kinsellas and colleagues reached their conclusion after painstakingly converting their telescope images into 3D in order to make accurate measurements of the numbers of galaxies at different times through the universe's history. They also used new mathematical models which allowed them to infer the existence of galaxies which the current generation of telescopes simply can't see. This led to the surprising realization that in order for the numbers to add up, at least 90% of the galaxies in the observable universe are actually too faint and too far away to be seen. Kinsellas says it boggles the mind that over 90% of galaxies in the universe are yet to be studied. In analysing the data, Kinsellas and colleagues looked more than 13 billion years into the past. This showed them that galaxies weren't evenly distributed through the universe's history. In fact, it appears there were a factor of 10 to 20 more galaxies per unit volume of the universe when the universe was just a few billion years old compared to today. Most of these galaxies were relatively small and faint, with masses similar to those we see in the satellite galaxies surrounding the Milky Way today. These results are powerful evidence that a significant evolution's taken place throughout the universe's history, with galaxies constantly merging together, dramatically reducing their total number. The findings therefore provide verification for the so-called top-down formation of structure in the universe. This decreasing number of galaxies as time progresses also contributes to the solution of Olbers' paradox, why the sky is dark at night. The astronomer Heinrich Olbers argued that the night sky should be permanently flooded by light. That's because he thought there was an unchanging universe filled with an infinite number of stars, so every single part of the sky should be occupied by a luminous object. However, our modern-day understanding of the universe tells us that it's not infinite and static, but is in fact finite and dynamic. Kinsellas and colleagues found that there is in fact such an abundance of galaxies that, in principle at least, every single point in the sky should contain at least part of a galaxy. However, most of these galaxies are invisible to the human eye and even to modern telescopes, owing to a combination of factors including the redshifting of light due to the universe's dynamic nature and the absorption of light by intergalactic dust and gas, all combining to ensure that the night sky remains mostly dark.